up, guys? So today we're moving into another lesson in Unit 10, which is going to be dealing with something called circumference and arc length. So you guys have already dealt with circumference before in your earlier years of math. That's just the distance around the circle. But today what you're going to be dealing with is something that you haven't seen necessarily before, is we're going to be using the circumference to find the arc length of a circle, so the distance between 2 points on that circle. So let's go ahead and jump into that. All right, so looking at our key points, the first thing we're going to look at is how do we find the circumference. So remember, circumference is the distance all the way around the circle. So there's two different ways you can find the distance around the circle, which is the circumference. The first one is to use the diameter. Remember, the diameter is the distance all the way across the circle from A to B here, so is your diameter. So if you knew the diameter, I would literally just have to multiply pi times diameter to get my circumference, okay? If I know my radius, which that's going to be half of the circle, that means I would need to double it to get the diameter. So that's why my other formula is 2 times pi times r. So I'm doing 2 times the radius and then multiplying that times the pi to give me my total circumference. So ladies and gentlemen, those are the two ways that you can find circumference, but it's technically the same way because it's using just another piece of information to do that, okay? Now to find arc length. So the first thing I want to talk about is what do I mean by arc? So for instance, if I have a point here and a point here, the distance on the circle between those 2 points is known as an arc. So if you heard the term put an arc on it, like if somebody's shooting a free throw, put an arc on your shot, or throw it up in the air and look at the arc, you're looking at that arc from point A to point B there, and that is going to end up being your arc. To find that arc length, we're basically going to take the circumference and we're going to multiply it by the ratio of the central angle, which is going to be this, which is theta, over 360. So it's the same concept whenever we did sector area. We found the area of the circle, then we multiplied it by that ratio to find the piece of my pi. I'm doing the same thing here, but I'm doing it with circumference now. So I'm going to take the circumference, that's what these two things are, and I'm going to multiply it by the ratio of the central angle over 360 in order to get my entire arc length, ladies and gentlemen, okay? So we're going to take these two concepts and we're going to apply it to our examples here. All right, looking at example number 1. So the first thing it asks me is to find the circumference for a circle with a radius of 18 centimeters. So right now they're giving me my radius. So that means if I look at my formulas up top to find the circumference, I'm going to do 2 times pi times the radius. So that means all I need to do is plug in that radius there. So circumference is equal to 2 times pi times 18. So if I do 2 times pi times 18, that is going to end up giving me 113.097. So I'm actually going to round that to the tens place, which is going to be giving 10. So that would end up being your circumference, which would be centimeters all the way around. So about 113 centimeters, pretty simple, okay? Let's jump over to example number 2. All right, so on example number 2, it says the circumference of a circle is 21 centimeters. What is the diameter? So I am needing to find the diameter. So if I look up top at my formula that I have on my paper, the one that uses the diameter is just pi times diameter. That's what it's going to end up giving me. So they gave me my circumference, which is 21, and then now I just need to solve for my diameter. So I know I'm multiplying pi times diameter to get 21. So to get the diameter by itself, I would then have to return divide by pi to get rid of that to get d by itself. So I'm going to do 21 divided by pi, and that's going to give me 6.68 rounded to the tens place. So my diameter would in return be 6.68 centimeters rounded to the hundredths place there, okay? So again, plug in what you know and solve for what you don't know is the idea behind this one, okay? Let's jump over to example number 3. All right, so on example number 3, it wants me to know what is the length between arc M and N. And I want to let you in on a little secret. In math, if they list an arc with just 2 letters, that means the shortest distance between those two. So the shortest distance between these two is going to be from here to here. And just so y'all know, this is gonna be 85 degrees. It's kind of jumbled up and looks weird, okay? So that would be 85 degrees right there, okay? So I'm gonna be finding the arc length of MN here. So I know to find arc length, if you look, they gave me my radius, so I'm gonna be using the formula for the radius. So first I have to find the circumference of my circle, which is 2 pi r. And then I'm gonna multiply that by my central angle, which is 85 over 360. I'm gonna go and plug in my radius over here as well. So my radius here is gonna be 12. So I'm gonna put this in parentheses 12. So literally all I have to do is multiply all this out. So 2 times pi times 12 times 85 over 360. When I click enter, that should give me 17.8. So that's going to give you 17.8, and that's going to be centimeters. So the arc length from M to N is going to be 17.8 centimeters. So again, I found my total circumference by doing this formula here, and then I multiplied it by the ratio because 85 is representing that piece of the puzzle. So when I multiply it times that fraction, it's basically giving me that piece of the circumference. So that would be the distance from M to N there, okay? All right, lastly, looking at example number 4, it's saying, what is the length of the arc PQR? So earlier on example number 1, we only had 2 letters. Remember, that's the distance closest to that. It wouldn't be the other way around. If they give you 3 letters, that means I actually have to follow that list of letters. So they want to know what's the arc length of P to Q to R. So they want to find the arc length of that entire thing. So the one thing you need to notice right now is I do not have a radius. So I'm going to go ahead and just say the radius is 6 inches. Let's go ahead and go with 6 inches. Okay, because I didn't put one on there. Okay, but the one thing that we need to notice is this angle right now is 145. So I need to find the rest of the circle. Okay, so I know the whole circle is going to be 360 degrees. So I'm going to subtract 145 from that, and that's going to give me a central angle of 215 degrees. And so now I've been given my radius, so I need to find the circumference. So I'm going to do 2 times pi times the radius, and I'm going to multiply that by my central angle over 360 to get my piece of the puzzle cut out, or the piece of the arc cut out. Okay, so my radius is 6, so 2 times pi times 6. My central angle is 215, so 215 over 360. And now I'm just going to multiply all this out. So 2 times pi times 6 times 215 over 360 is going to end up giving me 22.51. So your final answer would be 22.51 inches. So again, I have to find my total circumference, and then I have to multiply it by the ratio of that arc, or that central angle, over the total amount, which is going to be 360 degrees. It's basically just cutting out that piece there, okay? All right, guys, so if you need a little bit of help, please call us over. We can give you a little bit more help if need be, or a little more conversation to help you guys understand this. Other than that, good luck on your skill check. Holler at me.